Hello everyone, I'm Dr. Buddhika Liyanike. So today I would like to talk about colligative properties, boiling point elevation and freezing point depression. Colligative properties. They are properties of solutions that depend on the number of solute particles, not on their identity. Colligative properties depend on the concentration of solute particles regardless of whether these particles are atoms, molecules or the ions. The primary colligative properties are vapor pressure lowering, boiling point elevation, freezing point depression and osmotic pressure. So today in this presentation I would like to talk about the boiling point elevation and the freezing point depression with some examples. Equations for boiling point elevation and the freezing point depression. The first equation is for boiling point elevation. You can see delta TB is boiling point elevation, that is equal to boiling point elevation constant Kb times m. M we called molality. Same way for the freezing point depression or freezing point lowering is equal the freezing point lowering constant times molality. So molality we can define as moles of solute divided by kilogram of solvent. So then the units for the molality should be the moles per kilogram. So let's apply these equations for the problem solving in the next slide. Boiling point elevation. The boiling point of solvent increases when non-volatile solute is added. You will know the pure water boiling point is 100 degrees Celsius. However, if we dissolve non-volatile solute like sugar, table salt that is sodium chloride in water, the boiling point is increases above 100 degrees Celsius. This is we called boiling point elevation. So 1 mole of non-volatile solute in 1 kilogram of water increases boiling point by 0.51 degrees Celsius. So this is we called boiling point elevation constant. Let's go and find out example. What is the boiling point of solution containing 1.0 moles of sodium chloride in 1 kilogram of water? So here I would like to explain in two different ways how we can calculate the new boiling point of the solution after we dissolve 1 mole of NaCl. Method 1. So with the knowledge of ionic compound, we all know sodium chloride is the ionic solid. So when it dissolves in water, sodium chloride breaks into sodium plus ion and chloride minus ion. So initially we have NaCl 1 mole. So initially at the beginning we don't have any ions present. After we dissolve sodium chloride solid in water, sodium chloride breaks into or dissociate into sodium plus ion 1 mole and chloride ions 1 mole. Now we have 1 plus 1, 2 moles in the solution. So 1 mole of solute increases boiling point by 0.51 degrees Celsius. But in the solution now there are 2 moles present. So the boiling point elevation then 2 times 0.51 is equal 1.02 degrees Celsius. The second method is applying the equations we explained in the previous slide. The boiling point elevation is equal boiling point elevation constant times molality. So here boiling point elevation constant is 0.51 degrees Celsius times molality is number of moles, that is 2 moles present in the solution divided by the kilogram of the solvent. This is 1 kilogram of water. So after you solve this, boiling point elevation is 1.02 degrees Celsius. The pure water boiling point is 100 degrees Celsius. So the elevation is 1.02. So now boiling point after we dissolve NaCl is 101.02 degrees Celsius. Freezing point depression. The freezing point of solvent decreases when non-volatile solute is added. In pure water, freezing point is 0 degrees Celsius or 32 degrees Fahrenheit. If we dissolve 1 mole of non-volatile solute in 1 kilogram of water, that decreases freezing point by 1.86 degrees Celsius. Calculate freezing point of a solution that contains 1 mole of ethylene glycol in 2 kg water. So ethylene glycol is a covalent compound. Therefore, no ions produced in water. Let's apply the equation. Freezing point lowering is equal freezing point lowering constant times molality. So freezing point lowering constant is 1.86 degrees Celsius times molality. Molality is moles of solute divided by kilogram of solvent. So here moles of solute is 1 mole of ethylene glycol divided by 2 kilogram of water. So after you solve that, the lowering is 0.93 degrees Celsius. So initially, the pure water freezing point is 0 degrees Celsius. Now lowering is 0.93 degrees Celsius. So 0 minus 0.93, new freezing point is below 0. It is negative 0.93 degrees Celsius. I hope now you will understand what are the colligative properties and how we can solve problems using boiling point elevation and the freezing point depression. What are the applications of colligative properties? Ethylene glycol or propylene glycol is added to water in car radiators to lower the freezing point and raise the boiling point. Salting rods. The salts, usually sodium chloride and calcium chloride, is spread on icy rods in winter. The salt lowers the freezing point of water, causing ice to melt even when the temperature is below 0 degrees Celsius. Food preservation. Adding salt or sugar to food creates high osmotic pressure environment, which dehydrates bacteria and other microorganisms, inhibiting their growth and preserving the food. The reverse osmosis, the water purification. The pressure is applied to a solution to overcome the natural osmotic pressure, forcing water molecules through a semi-permeable membrane and leaving solute particles behind. This is used for desalinating seawater and purifying drinking water. Another application in pharmaceuticals. Osmotic pressure is crucial in designing a controlled release drug delivery systems where the drug is released at a consistent rate over time. Please subscribe to the channel and comment any specific area if you would like to discuss in the future. Thank you all for watching.